Hello again, fellow Jeti users. I've done previous videos about how to program the sequencers in Jeti, but I've got a special little project here that I thought I'd show you and show you the practical application of running 3 sequencers together, and they're all programmed in a little bit different ways, and how to go about really programming a practical experiment. Here we've got 3 servos. One to operate the fairing, which goes up and down, one to operate the elevation of the guns, and one to operate the turntable. The model is a Bolt & Paul Defiant, and if you don't know what the Defiant is, think Hawker Hurricane but with a gun turret behind the pilot. So this is still under construction, but this is what happens with a simple on-off switch on the transmitter. And then I switch it off. Now,
gun turret off.
There we go. All done through sequencing on the transmitter. So let's have a look at how that was all built up and the shortcuts to doing it the easiest way. If you'll give me a second, I'll just switch it off so that it doesn't activate whilst we're moving the controls. Okay.
Signal lost. Signal lost.
Yes.
Signal lost.
Right. Now, in the sequencers, as you may remember, you set travel points. And if I was to try and use the sequencer to set the exact rotation of bits and pieces, then you're going to have to remember precise numbers because we don't necessarily want it traveling 100%. So I thought the simplest thing to do is use the servo setup, for instance here in turret, use its subtrim and its maximum travels, same with the gun's elevation, again no subtrim but maximum travels, same with the fairing, use its travels there, to get the endpoints correct, so that when we go into the sequencer, you only have 3 numbers to use, plus 100, 0, and minus 100. If I hadn't used the servo setup here, then each of those 3 servos would have to have different neutral points, different endpoints, and you'd have to keep programming ups and downs in the sequencer of all these different numbers. So by doing the endpoints and neutrals in servo setup, I've made life a lot easier in the sequencer. So we go into Advanced Properties, Sequencer. Oh, incidentally, in case you're wondering, the turret here is operated by a standard Futaba servo. The whole thing just lifts out nicely. You can see we've got a couple of pegs under there, underneath the turntable, and they engage in the 2 slots in the top of the Futaba servo. Now, a standard servo rotates, well, 90 degrees, give or take, when you give it a 100% signal. So I modified it with 2.2 kilo ohm resistors at each end of the feedback pot, so that it will now rotate about 160 degrees. I was looking for 180, but it does actually hit either mechanical or electronic end stops when it gets that sort of travel. But at least it allows me to get it rotating almost completely left and almost completely right. So how do we go about building up the sequencers, and what are the different options that we choose for it? Well, sequencer 1, as you can see, is the fairing. That's the bit that goes up and down between the guns to allow it to move. And let's have a look at its advanced properties to understand what's going on. It's overwriting a channel, obviously. The type of path is symmetrical. In other words, when we switch off, it'll just start at the right-hand end and go back along the path to the left-hand end. Cycling is off. because obviously I just want this thing to go down and stay down, or come back up and stay up. Okay, and so what it does is it starts here at time 0. The value is minus 100. So I'm not having to remember and write down, oh gosh, the fairing down is minus 110% or minus 97%, because we've done that in the servo setup. So all we have to do, remember here, is the values of hundreds, plus or minus, and then the 0. So the fairing at one end of its travel is minus 100%. And then if we look along as the time moves along, I've given it 0.7 of a second, so it doesn't just sort of snap up or down, moves a bit gently, to go to the other end of its travel, which is plus 100%. The dotted line here is 0%. So that's minus 100, that's plus 100. Travels to the other end of its travel, as defined in servo setup. And then we give it a couple of seconds to reach this end point here, still at plus 100. And it gets to the end there and it just stops there and stays there. And you're thinking, why have you programmed staying in that position for a couple of seconds when it's going to just stay there if we stopped here anyway? Well, the reason being, remember, I've got a symmetrical path. So when I switch off the whole maneuver, it will start here, run backwards for 2.3 seconds, because this was at 0.7 seconds. It'll run back through that for 2.3 seconds, going nowhere, giving time for the turntable and the guns to return to the rest position before the fairing comes up, because the fairing sits up in between the guns, so everything has to be back in position before the fairing can move up. Okie doke. What happens if we come down to sequencer number 2, the turret on its little turntable? There appears to be no curve here. What's going on? Whereas if I switch the turret on,
Gun turret on.
thank you, a curve starts appearing. Switch it
Gun
off,
turret off.
no curve. Let's go down into advanced and see what's going on here. Okay, again it's the turret. This time we've got an asymmetrical path. That means that when it gets to the right hand end of the path, it won't go backwards along that same path when I switch it off. It will go to a completely separate path. Okay, and that's what allows me to immediately move the turntable back to the neutral point when I switch it off. Otherwise, if I'd said symmetrical, wherever it had got to in its sequence, it would just start working back through the sequence, and it could be quite a long time till it gets back to the neutral point. Also, I've switched on cycling, so that as it starts, it moves along to the right-hand end of the curve, and then it works its way back along the curve, gets to the start, works its way back along again, and it'll just keep going backwards and forwards all day long until I switch it off. But the return curve is asymmetrical, remember, so it doesn't work its way back along the up, down, up, down, up, down curve. It takes the curve for the way back, which is to jump back to the start, and then it follows this path through, and then it takes the return curve, which is dunk, and then works the way through again. So it'll just keep cycling backwards and forwards. Okay, let's have a look at the curve itself then. So at the moment it's in the off position, and the return curve is a single point at value 0. In other words, at the middle. And remember, the middle was actually defined in the servo setup. It's something like minus 20%, I think. And that's why it's great to do these in servo setup. You set it up once and you don't have to remember any of these numbers. You just come here, 0, plus 100, minus 100, that's all you have to remember. If I switch the sequencer on, the outgoing sequence comes. So it takes a second of doing nothing to allow the fairing to move, and then it goes gently every 2 seconds between plus and minus 100%. Although here, I let it swing out the right-hand side, come out here, do a wiggle on the left-hand side only, and then it comes out here, and boom. Why did it jump back to the start instead of following the path? Because it's an asymmetrical path going backwards. And remember, the backwards path was a single point, so it jumped that single point backwards. The great thing being, doesn't matter where it is here, if I switch it off, bang, it's going to go straight back to the neutral point. And then Q3 is much the same. If we look at its advanced, very similar to the turret, an asymmetrical path so that I can make it jump back to its resting point when I switch it off, and cycling. So again, of course, it does the jump back when it reaches the end of its path. If we have a look at that again, guns, there's a single point when they're switched off, but this time, unlike the turret, which comes back to its middle point, 0, when they're at neutral, it's at 100%. In other words, the guns are fully lowered. And if I switch it on,
Gun turret on.
the guns jump upwards, pause for a moment, and then off they go on a much faster up-down than the side-to-side rotation, so that the two of them are not in sync. Otherwise, it would just look like a sort of rocking backwards and forwards wave. And I've also programmed it for a shorter total time so that its jump back is out of sync with the turntable jump back. Okie doke. So there you go. There are 3 sequencers operating basically one gadget, but using different versions of the symmetrical or asymmetrical, different versions of cycling or not cycling, and showing how you can control the neutral points, endpoints, and make them jump backwards or not as required. So I hope that little explanation was of some help to you, or perhaps some inspiration to do some more advanced sequencing of your own. Bye for now.